In this video, we're going to talk about setting up physics through blueprints in Unreal. And if you come from the world of Unity, you'll see that this is a little bit easier in some respects because by default it assumes, that most games that you're going to use, especially if they're 3D, you need to make sure that objects can't collide with each other. So, it sets up some default settings for pretty much anything that's an actor. So we're going to be able to turn basically everything that has a mesh on it into a physics object, which is pretty sweet. I'm going to start by just grabbing a cone here, putting it in my scene, raising it a little bit, and I'm going to set its location mainly so that I can drop something on top of it, just so you can get an idea of what I'm doing here. So it's going to be 0, 0, and you'll notice one thing in the transform is that there's this mobility, static, and stationary, and movable. And if you have an object that's set to static, even if you turn on physics for it, it's not going to actually be able to move. Now, by default, if I come down and select physics, it's going to change this for me automatically. This used to not be the case in the older versions of the Unreal Engine, and so fortunately, it's been changed to, for the better. So the first thing I need to do really is to say simulate physics. And as you notice, this is just one of the settings under the actor. And so I can select this little simulate physics box. And then I'm going to save my scene, raise my cone a little bit. I'm also going to take my player start position because I want to be able to actually see what's going on. So let me get a little bit closer here so I can move my my start position. Oops, I'm grabbing the wrong arrow there. So we set that, and now if I hit play, I'll be sort of behind, and you see my cone just follows automatically. This object, that we're standing on the floor is basically an object that is set with some physics properties in order to block things from falling through it. So, by default, many of the things that you put in the game are going to automatically be, blocking or physics bodies. So there are certain settings that we can set with that. So let's take this cone and it's maybe a little bit high. So we're going to lower it a little bit here. And then we're going to take a sphere, put it in our scene. And this is why I wanted to set its position, X and Y position to 0, 0, 0. And then I'm going to raise it up a little bit so that when I hit play, I can watch it and I can see it's floating there, not doing anything, because of course I forgot to turn on physics. So let's go back to the sphere that I added and scroll down to physics, simulate physics, and just like that, the ball falls onto it. So, with the default actor and default pawn, I can move around my scene pretty easily. So it's kind of nice. I can set things up. These are what we just basically call dynamic physics objects or physics bodies. And they'll, gravity will affect them. They'll collide with each other by default. But it's worth investigating, what are the settings in the physics system here so that you understand. One of these is enable gravity, so if you have this checked, then gravity is going to be applied to the object. So if you wanted something to sort of float, you could turn that off. To give you an example, we can turn it off and it'll be floating and it won't land until the cone lands there. Now that's kind of amazing. Usually you get enough error in there that the object won't stay perfectly balanced like that, but that's kind of why I put the cone there, because it's kind of funny. So in terms of, constraints, we'll get into a little bit more about this later, but this is similar to what you've seen in other game engines like Unity, where you can say, well, lock a position on the x-axis, the y-axis, or the z-axis. You can also lock its rotation so it can't rotate at all. And then there's different kinds of modes where you can, decide like what kind of freedom it's going to have based on how you want to constrain that object. All right. You can also set some settings for ignoring radial impulse or radial force. And these are to keep, the object from having these forces applied to it. When we move objects around it in the game engine, if we want them to interact correctly with other objects, we generally want to make them, responsive to these forces. But there might be cases where you want to turn it off so that you can't, apply those forces if they get hit by other objects. So these are the basic sort of physics settings here. The most important of these, generally what we're trying to deal with, are collisions. And the collisions, if we want to actually get collision events that we can handle in Unreal, what we need to do is select this generate hit events checkbox. And then this will allow us to create a blueprint based on that object, which will then get these hit events that we can then respond to. Now let's add a kinematic object to the scene. A kinematic object is one where you set its location and its position, its rotation, even its scaling, and then the physics bodies can react to that. But by default, if you have a kinematic object, you can force it to move through any other object because, it's going to respect your code. It's assuming that you know what you're doing and that you intended to do something like that. So I'm going to do this by adding a cube into my scene. And let's raise it a little bit. And then I'm going to do some scaling to it so that we can make it look more like a paddle. All right, so we kind of got a square here, and then I'm going to stretch it out along this way. All right, so that looks more like a paddle. And what I want to do is create a script to it that is going to rotate it. So I'm going to go ahead and add a new blueprint to it. And this is going to go into my physics directory. And I'm just going to call this paddle. Paddle BP for paddle blueprint. This will create the blueprint and add it to it. And as you can see, that's my scene here, what the object looks like. And what I want to do is in the event graph, I'm going to come over here to TIG. And I'm going to call a method called add actor world rotation. Oops, it didn't select it. Add actor world rotation. There we go. This is simply going to add a certain amount of rotation around a particular axis. And I'm going to try to rotate around, let's say, the y-axis. Let's make this 90 degrees. And let's take a look really quick to make sure this is the orientation that I want it to rotate around. Actually, I might want to rotate around the z-axis, but we'll take a quick look just to figure out, which way it's rotating. Okay, it's not rotating at all. And part of the reason, of course, is that if I click on this object, I'm going to see that it's static and I need to make it movable. So let's go back to this. Okay, so it's definitely rotating way too fast. I forgot to scale my my paddle, so let's come back over here. And we're going to, instead, we're going to go ahead and create a rotator. So we'll say make rotator. And from this, we're going to say scale rotator. So you always want to scale these things by how much time has elapsed so that it's a frame independent value. Well, if I could just grab this, there we go. And then I'm going to take this as my input into my delta rotation. This will now rotate at the right speed. But I did, like I said, I'm pretty sure I wanted to actually go around the yaw. And so I'll save this. And then I will go back to my level. And we'll take a look here. There we go. Now it seems to be moving. It's not moving very fast. So let's make it move a little bit faster than it is. Oh, because I typed 9, not 90. That did look like it was about 9 degrees per second. Right, just to make it clear, these are in degrees. And, if you're using C++, a lot of times it's in radians, so just make sure that you're translating correctly between those. And I'm going to close this up, because we don't need that. Don't need my settings. And I don't need that. Right, so now we're going to hit play. We'll be able to see that this rotates. And you notice that it already knocked the cone sort of out of the way. So there's definitely something working kind of the way we want it to. As I said, I didn't even do anything. And by default, this object has collisions enabled. And how do I know? Well, I have this object selected, and I can look in its physics settings, and we can see that this is set over here in block all dynamic. So block all dynamic basically says that anything that is a dynamic object, so anything that is moving is a movable object, is by default a dynamic object, a blocking dynamic object. And you can change these collision presets. If you open this up, you'll see like what it's going to block. So there's trace responses, and that means they're going to be able to hit these objects. Traces are actually like a ray is used into the scene to figure out which objects it intersects with. And then object responses, these depend on the kind of object that's defined. So you can set something, for example, to world static or world dynamic or things like that. So this is set to basically block all dynamic, and it has these settings there. And if you look at the object type, it is also world dynamic. So that's how we know, does a world dynamic object block another world dynamic object? And the answer is yes. But if you were to, set up a different kind of object type, then you would see that these might change. So this is a collision, what we call a collision preset. We can set a custom one if we wanted to by clicking on this custom right here. And then we can then decide exactly how it's going to interact with other objects. Now, it's possible that you might want to create something that doesn't interact specifically with another object. And we can do that by creating new versions of these object types. So if I come over here to my scene, and I'm going to take my cone and I'm going to move it a little bit over. We'll hit play here. Let's see if it misses it. It still hits it a little bit. What I'd like to do is for my paddle to pass through the cone. So if I go into the project settings, I can go to settings here, and I can select project settings. I have my window popped up here. I can then look at collision, and collision will show me this set of object channels. I can create my own object channel, so let's just call one paddle. And then we can create another one, and we'll just call this cone. So there might be cases where you specifically want to, change the behavior between two objects, and this is generally how we do it. So I'm going to come over here to my cone now, and let's go to its collision settings, and it's preset as a physics actor. So I'm going to have to make it custom, and then after that I can change the object type. And so here I can select cone. Now, if I look here, you will notice that we have some new responses because we now have a paddle and cone object type. And so I want my cone to ignore any other cone, but also paddles. They don't have to ignore each other, but we can set that. So that will now ignore the paddle. And then just to be safe, I think once you have one thing on ignore, they'll both ignore automatically. But we'll go ahead and click on the paddle here. So we'll set the object type here. So we made it custom, and then we can make this one be the paddle, since it's the paddle that's rotating. And again, we'll do a similar thing where we'll say, well, if it's a paddle interacting with a cone, we want to ignore it. Paddles and paddles, maybe they should ignore each other too. So now that we have this set up, we'll see, let me move the cone back over to, it's kind of an original position, which was at 0 here. And then when I hit play, it should be fairly obvious that that ball ran into me, but that the paddle is passing through the cone. So you can set up these sort of, object trace response and object-object responses by setting up your own custom type there. So that's pretty neat. But we can also change the actual properties of the objects by creating physics materials. You did this in Unity also, and so we can do the same thing here. If we right click on here and say physics, and then say physics material, and then it's going to ask for the class that we're inheriting from. We'll say the physics material, and then we'll call this bouncy physics material. And what we want to do is do something silly like change the restitution to 1. So the density is 1, but we're going to change this to 1. And that should be good. Then we can come back over here. I'm going to select the floor because I want the floor to be bouncy. And I don't have to simulate physics on it, but I can set the physics material on it for collisions by just dragging it over here onto my physics material override. And then I'm going to create a new sphere, And we'll also raise this up so that we can see it bounce. And I'm going to drag the physics material onto this one. And then this one will bounce. And let's play. Oops, of course it has to have physics simulated on it, which I apparently forgot. So let's go ahead and turn that on. Simulate physics. And just to show you, now it's movable. So you see it bouncing, and it should continue bouncing. And just to point out one thing, if I stop this, even though this was set to movable and I have is physics, set on it for simulate physics, and then I come back over here and I make it say static, if I hit play, it's going to not move again. So you just really need to make sure that you set, that it's set to movable if your object isn't doing what you would like it to do. The last thing we'd like to do is maybe create like a trigger or something so you can get an idea of how that works. And so we're going to put a cube in here, and on this cube we're going to add a blueprint, and let's go ahead and put it in our physics folder, and we'll call this trigger BP. Hit create blueprint, and once I do that, I can then go into its event graph, and here we have on actor begin overlap. And so when that happens, I'm going to just print something to the string so I can know that I have been triggered. All right, so this will now print something every time I get an overlap event. But in order for that to happen, I need to go over to my physics object, and I need to, first of all, say simulation generate, well, I don't have to do generate hits events, but I need to say generate overlap events and select that. I also need to change my object type because right now my collision presets are the default, and I really want like an overall overlap all dynamic. So it'll overlap, anything that's a dynamic object. And this way, when I hit play, I can walk through it, or I can pass through it. And you can see that I get a triggered up there in the left corner of my screen every time I pass over it. Now, obviously, if you don't, you could make the mesh invisible or not put a mesh on it, and just put a body around it so that it will be visible. Not be visible, and then you can have a trigger that's not that someone can't see, but when they walk through it, something will be triggered, and you can fire off events based on that. The same thing goes for hit events. When we had this cone, for example, and it gets hit by something, we could add a blueprint to it. And again, we'll put this in physics, and we'll create the blueprint. And then in the event graph, we can go here and right click and say hit. Well, we want to say maybe event hit to narrow down what we're getting. And so now this will fire whenever we get a hit event. And so let's do a print string. And here's this is going to be my component that was hit. This is the other component, the other actor. This is the other component that was actually hit. So maybe if it's like a mesh or something, you can get that specifically. And so, you could grab something out of here and print, what you were hit by. So, I think it's get name, get display name. And we'll just pop this in here as the thing we get hit by, and compile that. And then I'm going to come back over here to my setup. And what I want to do with my cone is make sure that it generates hit events. See, by default, it's not going to generate these, so that you don't waste all that time generating them for objects that don't need them. And so now you can see, anything that is hitting, it's hitting the floor constantly. So, or it was hitting the floor a bunch of times, and so it got all those floor messages, and when the sphere hit it, it also got hit messages from that. So you can watch it again, and you can see sphere pop up there a few times. And so that's how you get the events, all of these in blueprints, and you sort of react to them, and you can, code up situations just simply using blueprints on your objects for setting up physics.